All right, so today's lesson is going to be on simplifying radicals, and this is the last of the things that we're going to review. This is our last lesson in algebra for the whole year. So radicals are when we have a square root sign. So we need to simplify what's underneath here. This number 112, if I were to type it into Desmos, take the square root of 112, it's going to give me a long decimal. So it is not a perfect square, but there are some factors of 112 that I can take the square root of, and I need to figure out what those numbers are. So this is where we did the factor trees, and that seemed to be the method that everybody preferred. So I need to think of numbers that I can multiply together to get 112. Well, there's not a whole lot of those that I can think of off the top of my head, but it's an even number. So I'm going to go with 2 and 56. Okay, so if you don't know where to start with something small, something easy. If you still have no clue where to start, just pull up a calculator, pull up Desmos, and type in the number and just start dividing it by things. If it divides into it evenly, then those are your factors. So the number that you divided by and the answer you got are the two numbers that would be your factors that you can multiply together. So 2 is a prime factor, so I'm going to circle it. I'm done. Can't factor it any further. 56 is not a prime number. I can keep factoring that. So the numbers that I can multiply together to get 56 are 7 and 8. 7 is a prime number, so I can circle that also. I'm circling them to tell myself that I've factored it as far as I can go. There's nothing else I can do from there. 8 is not a prime number. I can continue to factor it. 8 will factor in to 2 and 4, and 4 will factor once again into 2 and 2. So now everything's circled. That means everything's prime. I've factored 112 into all of its prime factors. So I want to look for pairs. Notice I've got a pair of 2's right here. So I can circle those a second time. Those are going to come outside of my square root. But because I'm taking the square root of it, I'm only bringing 1 out. So I'm going to bring a 2 out in front. I only have 1 7, so that's going to stay underneath. I can't do anything with that. But I have another pair of 2's right here that I could circle. So I can bring a second 2 out in front. The 7 is the only thing left, and so it actually has to stay underneath the radical. I didn't take the square root of it. These two numbers in front here, I want to multiply those. So that's going to become 4 times the square root of 7. So this is something that you're going to use a lot in geometry when you're using the Pythagorean theorem. I think you guys have been introduced to that in middle school. But when you're using the Pythagorean theorem, you're taking the square root of things. And we don't want to leave it like this. We want to simplify it as much as we can. So that's something you're going to see a lot of in the future if you take geometry. So 4 times the square root of 7 is the simplified form of the square root of 112. Let's do a second one. This one has variables, and I'm actually going to throw a number out in front of there because you might see that sometimes too. So while I'm doing most of the work, I'm actually going to ignore the 3, but this I'm going to factor out, and I can factor those too. X squared is x times x. Y cubed is y times y times y. Now let's focus on the 48. So numbers that multiply together to give me 48, I'm going to use 6 and 8. Neither of those are prime, so I need to continue factoring. 6 will factor into 2 and 3, which are prime numbers. 8 will factor into 2 and 4. 2 is a prime number, but 4 is not, so I have to keep going. Now I've got all my prime numbers, and I've got all of my variables simplified as far as possible. So I could circle those two so I don't forget about them. So things that I have pairs of are going to come out from underneath the radical. I have a pair of 2's right here, so I'm going to pull a 2 out. I have another pair of 2's right there. Kind of hard to circle these, but so I have that, so I'm going to pull another 2 out. This 3 does not have a pair, so it stays underneath the radical. I don't want to forget that I had that 3 out in front, so I need to write it out in front again. Actually, going to move this over. Now I want to look at my variables. I had a pair of x's, so an x comes out. I had a pair of y's, so a y comes out. One y was by itself, so it stays underneath the radical sign. I apologize. I'm running out of room a little bit here. I need to simplify things. I need to figure out what 2 times 2 times 3 is. So 2 times 2 is 4. 4 times 3 is 12. So I'm going to rewrite this as 12. The x and the y stay the same. And then I still have the square root of 3y. Sorry about that, I was kind of running out of room. But 12xy times the square root of 3y would be the simplified form of 3 times the square root of 48x squared y cubed. I wouldn't really say that either of those look particularly simple. This was a long one. I didn't want to just give you easy examples. But just remember, if you have a number out in front, you want to keep it out in front and multiply it by the other numbers that you pulled out. If you had variables, you're pulling any pairs of those that you have out in front also.